Hey everyone, we're going to look at number 10 in section 3.5. We have this function here, y is a function of t. We're to calculate this thing. Well, what's this thing? This is the Leibniz notation for the second derivative of y with respect to t. Okay, so the idea behind this is Leibniz notation for the first derivative is dy dt, which really is take the derivative with respect to t of the function y, right? The d over dt is the differential operator. And so if I take the derivative with respect to t of the first derivative, right, it's kind of derivative with respect to t of the derivative with respect to t of y. We say we have d times d, sort of d squared dt times dt squared of y, or d squared y dt squared. So all these notations I know can be somewhat confusing, especially the Leibniz notation, but that's how we use that. And then the vertical bar means evaluated at, and we're going to evaluate this as t equal to. If we're using the prime notation, this would be the same as y double prime of 2. And you might say, well, that's a lot easier notation than this. Yes, but we want you to make sure you're familiar with both notations. Both are used. Okay, so basically we've got to find the second derivative and then just plug in t equal to. Okay, so the first derivative of this function is using the sum rule. Take the derivative of 7t to the negative 3 and add it to the derivative of 6t squared. The derivative of 7t to the negative 3 is constant multiple rule. Pull the 7 out. Derivative of t to the negative 3, I bring power rule, negative 3 down, subtract 1 from negative 3, negative 4. Derivative of this one, 6 is a constant multiple. Derivative of t squared, bring the 2 down, subtract 1, I just get 2 times t to the first power, or 2t. Clean this up, 7 times negative 3 is negative 21, t to the negative 4, 6 times 2, 12t. There's my first derivative, right, dy over dt. Second derivative then, take the derivative of this. Negative 21 is a constant multiple. Derivative of t to the negative 4 is negative 4t to the subtract 1, negative 5. Plus, what's the derivative of 12t? Well, it's just 12. All right. Clean this up. Negative 21 times negative 4 is positive 84. T to the negative 5th plus 12. And then 84 t to the negative 5th, I would write as 84 divided by t to the 5th because I want to evaluate this. This is my second derivative. And so to evaluate that when t equals 2 just means plug in t equal 2 into this. So there it is. 2 to the 5th is 32. 84 and 32 have a common factor of 4. So I can divide top and bottom by 4. 4 into 84 is 21. 4 into 32 is 8. So 21/8 is the simplified fraction. And then we're adding 12. So how do I do that? Because they want the answer in fraction form. Well, I need the common denominator of 8. Well, 12 is the same as 96/8, right? Multiply 8 times 12 gives me 96. So 21 added to 96 gives me 117/8. And that is the answer to the problem. I hope this is helpful for this one.